We want to graph the given piecewise defined function. We are given f of x equals 3 halves x plus 2 if x is less than 4, and f of x equals the square root of the quantity x minus 4 if x is greater than or equal to 4. Let's begin by graphing the linear function f of x equals 3 halves x plus 2, but only when x is less than 4. And notice the linear function is in slope-intercept form, with the form f of x equals mx plus b. And again, we want to graph f of x equals 3 halves x plus 2, but only if x is less than 4. Notice the slope m equals 3 halves. Recall the slope equals the change of y divided by the change of x, or rise over run. And because b equals positive 2, we should recognize that the y-intercept is the ordered pair 0, 2. Let's go ahead and plot the y-intercept on the coordinate plane, 0, 2. And now because the slope is 3 halves, or 3 divided by 2, we go up 3 and right 2, find additional points on the line. Notice at this point we have x equals 2. Let's go up 3 and right 2 one more time. Notice at this point we have x equals 4. X equals 4 is not less than 4. To show this point is not on the line, we make an open point where x equals 4. So we'll change this closed point to an open point. Now we could sketch the line to the left of the open point. Let's find additional points. To do this, if we go back to the slope of positive 3 divided by positive 2, we could change the form to negative 3 divided by negative 2, which still simplifies to positive 3 halves. But now if we go back to the y-intercept, instead of going up 3 and right 2, we can go down 3 and left 2. So going back to the y-intercept, let's go down 3, left 2, multiple times. And now let's sketch the line, again, only when x is less than 4, which should be this piece of the line. And now we need to graph f of x equals the square root of the quantity x minus 4 when x is greater than or equal to 4. So let's clear this information. And let's graph the square root function by finding points on the graph using a table. So again, we want to graph f of x equals the square root of the quantity x minus 4 if or when x is greater than or equal to 4. So let's make a table of values. We'll select convenient x values, determine the corresponding function values, which will then give us points on the graph. From left to right, notice the interval starts at x equals 4. X equals 4 is in the interval x greater than or equal to 4. So let's select x equals 4, and now we'll determine f of 4 by subbing 4 for x into the function rule, which gives us a square root of the quantity 4 minus 4, which equals the square root of 0, which equals 0. This indicates the point 4, 0 is 1 point on the graph of the square root function. Recall when we're evaluating square root functions, the radicand, or the number under the square root, must be non-negative in order for the output to be real. We also would prefer to have integer coordinates, so we want to select x values that would make the radicand, or the number under the square root, a perfect square. For example, if we select x equals 5, f of 5 equals the square root of the quantity 5 minus 4, which simplifies to the square root of 1. 1's a perfect square. The square root of 1 equals 1, indicating the point 5, 1 is a point on the graph of the square root function. So again, 1 squared is 1 and 2 squared is 4. 4 is a perfect square. Notice for the number under the square root to be equal to 4, we have to select x equals 8, because 8 minus 4 equals 4. So let's select x equals 8. F of 8 equals the square root of the quantity 8 minus 4, which simplifies to the square root of 4, which equals 2, giving us the ordered pair, or the point 8, 2. Let's go ahead and plot these 3 points on the coordinate plane. We have 4, 0, we have 5, 1, and we have 8, 2. Notice in this case, when x equals 4, we do leave this a closed point because x equals 4 is in the interval of x greater than or equal to 4. So the closed point is on the square root function, not the linear function. So the graph of f of x equals the square root of the quantity x minus 4 when x is greater than or equal to 4, looks like this. And we now have the completed graph for the piecewise defined function. Before we go though, let's analyze the graph one more time. Notice at x equals 4, we have an open point on the line and a closed point on the square root function. And this is correct because x equals 4 is in the interval where we graph the square root function x greater than or equal to 4. X equals 4 is not in the interval x less than 4, which is for the linear function. I hope you found this helpful.